Welcome to our session. My name is Brian Warwick. I am a solution architect for Tata Consultancy Services in the Business Solutions Unit. Here with my colleague, Gaurav.
Thanks, Brian. Hi, everyone. I'm Gaurav Kakkar. I'm a solution architect at Tata Consultancy Services. We are both based out of Cincinnati.
Yeah. Thank you very much. It is next stretch time. No, I'm just kidding. That's actually part of our normal ergonomics thing that our wonderful company lets us stay in touch with that need. But today's session specifically is about our next generation microservices-based data and analytics solution. It's a very large name, and there is a lot of content. So just to preface today's session, we have about 45 minutes, a lot to cover from context, understanding the business and benefits of the solution, the features that are there. And so if we could, I'd appreciate if you have any questions or anything, hold those to the end. And if you'd like to talk to us, come up afterwards after the session. We'd love to talk to you as well. So the agenda, we're going to cover kind of the business problem of why we went through this venture and initiative with Red Hat and the vision behind it, as well as the solution itself, the benefits and the features. And then I will pass it over to Gaurav, who will go over the technology, the landscape, and the architecture, and then we will also finish up with a demonstration. So in the area of big data and analytics, when you think about how things have changed over the years, it's no mystery to the rest of us that the data explosion, if you will, and understanding of organizations, whether that's healthcare or banking and finance, manufacturing, wherever it is, the reality is that we've become more sophisticated in the way that we collect, the way that we understand the data. And as organizations begin to leverage that information, we began to see that there's a larger demand for the types of analytics that need to be done on top of that data that we have, as well as bringing all those systems together. So I think it's interesting when we look at the business problem, because human nature, as well as business nature, we tend to begin to move into silos. We have responsibilities, things that we know that we need to execute upon. And based on the data we have available to us, no matter what our role is in an organization, even though we say we want to work as a cohesive ecosystem, we do tend to lean towards that kind of siloed vision approach. And although that's good in some ways for execution, we still need to have the ability to execute upon all the data sources that are available to make better, insightful decisions. So the business problem that we look at kind of breaks down into two areas where we look at what were the roadblocks coming from that reality of siloed systems, as well as the customer impact, right? The customer could be an individual or an entity. Some of the roadblocks that we've seen really comes down to a lack of consolidation. So we know that one unit has data about a particular customer, but they're interested in one specific outcome, and yet another set of data that's available for that same customer, even though it has an outcome that may be somewhat variant, it still can lead to a better decision if those data sets were merged. We also look at dependencies. So when we begin to work in those silos, we will lean upon systems that we've always done, not knowing if there are any new ways, kind of evolution of that way of data processing. And then the customer itself does tend to show behaviors as well based on how they interact with you, the customer. So if you're siloing the way you execute, customers also going to have to go to different areas to get different answers, right? So if it's banking and finance or retail, they know they might have to talk to one customer service for one thing or go somewhere else online to get some other resolution. So that does tend to lean to maybe a churn risk or even dissatisfaction on loyalty. So our solution is to take the microservices-based big data and analytical solution is to take the hybrid cloud and container framework model and give this unified view of your customer. So when all the data comes into one place and you say, I'm taking structured and unstructured data about the customer, I'm going to have a better understanding about decisions I have to make to retain them or maybe even make their experience more pleasant, more pleasurable, and also gain new customers as well. And so we look at some of the features and things in a few minutes, but we wanted to take in all the types of analytics can be applied. So you're talking about predictive analytics, where we're looking at behavior of the customer. What are they doing? What can we determine about them that's going to happen next? We're also looking at some of the Clickstream data, so how they're interacting with whatever interfaces you provide for them, whether that's an application on your phone, whether that's a website, whatever it may be. We start tracking that behavior, and that lends a lot of data into what you might want to do to interact with that customer better, as well as next best action. So a lot of the insights we get with cognitive and AI tools, you look and see how an individual might prefer certain types of interaction, and also the data will lend yourself to that kind of decision making. So it's a holistic view. We definitely like to say the 360-degree view. I think that's been used quite a bit. I like the holistic view as well as a terminology, because as a customer for any industry, if that organization understands me, understands you, then it doesn't necessarily have to always be a big explanation from my side to get a solution. It can be an intent that's understood before I even ask for the problem to be solved. And then the benefits of this, I kind of talked about that already a little bit, but as you can see, we're talking about lead generation as well, not just retaining current customers. So we see a demographic of customers behaving in a certain way to the services and products we offer. How do I know what they're saying maybe on social media? Are they taking the reviews into account by the way they interact with us? And better informed decisions no matter what department you're in. So our solution does focus on one industry and one particular role for the sake of the demo, but no matter what industry you're in, it can be applied. So we kind of break down those differentiators as well. And this solution is powered by Red Hat OpenShift, a container platform. We do focus on the hybrid cloud. Obviously, every customer in here and anyone who deals with the cloud platforms know the reality of being able to interchangeable with the services that are available across all platforms. And Red Hat offers a lot of agility in that space, as well as the ability to develop applications from a DevOps approach. And I think one of the things that I really want to show today, and that Gaurav will go through the demo, is all about the interaction between all those different types of analytics that I mentioned already. Predictive, prescriptive, whether that's a cognitive AI kind of insight, or sentiment analytics that you'll see in a little bit. So now I'm going to go ahead and pass that over to Gaurav, who's going to cover some of the features that are available in our solution.
Thanks, Brian. Okay, so let's look at the features that the solution provides. So first and foremost, the main capability that anyone would look for such a solution is the ease in which we can ingest new data, and not just ingest, but also be able to manage that data that we are ingesting, right? Because when we start talking about a data lake kind of a framework, or a big data and analytics kind of a framework, while we want that the system should allow users to ingest as much data as possible, we also want that the data should be managed as well. We don't want any amount of data to be ingested just for the sake of it, right? So that is where we have built in a data ingestion framework as well, so which caters to all the different types of data sets that are available. So be it social media data, be it real-time data from different, like a Clickstream website, or any RDBMS system or flat files. So we have a framework that we have created as part of this particular solution that would allow us to ingest all those different data sets. The other important feature that we have is the ability to generate the kind of advanced predictive analytics using the machine learning algorithms that we have built in within the solution. So now that we have all the data that is being ingested into the platform, it is being stored within the platform. The real benefit that you would get out of the solution is once you start generating analytics out of it, once you start processing that data. So that is where a lot of advanced analytics capabilities is what would be required from such a solution to basically gain the insights into the customer's sentiments, right? So you talk about a lot of customers, be it a banking customer, be it a retail customer. What is the browsing pattern for the customer? Say, for example, if I talk about a retail customer, right? So what are the products that my customers are browsing? Based on that, how do I generate a recommendation for the customers so that I sell my products faster or in a better way, right? So it's basically understanding those kind of sentiments, not just from single channel, but from a multi-channel or an omni-channel kind of a platform, basically to understand those sentiments based on the data that is being ingested into the platform. So that is what we have as another feature as part of this particular solution. We're also providing a very easy integration system to cloud. Now, a lot of enterprises these days, when they start talking about cloud or migration to cloud, the very first thing that comes to our mind is cloud-first strategy, right? What essentially cloud-first strategy means is, while we don't say that everything can be migrated to cloud, it might not be possible that everything is migrated to cloud, but at least we have a strategy in place which allows us to migrate the components which can be easily migrated to cloud. So that is where a platform such as Red Hat OpenShift Container Platform also is very useful, because I can have an architecture wherein I'm creating a few projects on-prem, whereas as part of the same OpenShift cluster, I can also have some worker nodes lying in one of the cloud platforms. So when I'm ready as an application owner, when I know that my application is ready to be migrated to cloud, I can easily do that. And not just that, considering all the security reasons, right? We have started to hear about GDPR and other policies. So if I want my data to be still on-prem, but depending on the scale, I want my processing power to be migrated to cloud, that is something which is again possible thanks to Red Hat OpenShift Container Platform. So now once you have all the data generated, once all the analytics is generated, the data is being processed and stored into your databases, the final thing that we would want to do is the ability to visualize all this data, right? So that is where we have also created some advanced dashboards as part of this solution. We would demo that to you later during the presentation. So basically, a single dashboard which would show you all the business KPIs. Now, definitely, as Brian mentioned earlier, we have picked up a particular use case for the demo presentation. But then, as we mentioned earlier, this can fit into any domain, any industry, or any use case as well. Now, another very important aspect for this would be the security and controlled access, right? So now that you have all the data being ingested into the platform, we want our users to be able to consume that data, right? So be it a business user from the analytics perspective who would have access to the dashboards, to someone who would want to do, say, for example, like a self-service BI, right? I have data being ingested into the platform and it is being stored in multiple locations or multiple platforms, right? I want that data to be integrated in a single way so that I can easily consume that data and I can generate, or I can basically perform analytics on top of it, right? So that is where we also have built in the security and controlled access methodologies within the solution. Now let's look at some of the business drivers that would be there for the solution. So definitely when you look at all the structured data, unstructured data, the different data sources that are kind of typical for such a customer analytics solution, the main business drivers for this would be, basically you are moving away from a data-centric approach to a data-driven approach, right? So we want the insights to be driven by the data that we're ingesting into the system, right? So that is what would lead to some use cases, specific use cases such as customer retention, right? So once we start analyzing the patterns of our customers, once we start analyzing how the customers interact with the services that we are providing to our end customers, we can very well, we can easily define, we can predict what kind of browsing patterns they have, what kind of services do I give to my customers, so that we basically enhance their experience that they have with the solutions that we are providing. So that would definitely drive customer satisfaction as well, and it would definitely increase the customer loyalty as well, right? Now let's look at a few technical things which are part of the solution. So the technology landscape that we have, this is a mix of Red Hat suite of products and some open source software as well. So predominantly we have used the Red Hat suite of products as part of this particular solution. So we have, this is entirely built up on the Red Hat OpenShift Container Platform. So it's a microservices-based architecture. We are using JBoss data virtualization to basically integrate the different data components that we have as part of the solution, as I would show you earlier or later during the demo. We are also using JBoss AMQ, so that is basically being used for to cater to all the real-time data that is being ingested into the system. We are using cloud management automation. We are using operations network as well for all the monitoring and the operations part of it. We are using Ansible Tower for end-to-end automation of all the different data flows that we have in the system. We are using 3-scale AMP to basically expose these all the data that we are ingesting into the system. We want that to be consumed by the external consumer. So that is being done through 3-scale AMP. And last but not the least, all this data is being stored on ClusterFS. So when you look at typical enterprise data lake, right? So you would want a central data lake which is created out of all the artifacts that you push within the data lake, all the data that is being ingested to the system, right? So that is where ClusterFS comes into picture. It provides us capability to easily scale to petabytes of storage as well. So apart from that, the other open source softwares that we are using here is we are using PostgreSQL, MongoDB. So Depending on the use case, if it's an unstructured data, that goes into MongoDB. If it's more of a structured data or a calculated data, that goes into PostgreSQL. And then for processing, we are using Python and Apache Spark. So depending on the kind of algorithms we have generated or the kind of logic that we have, the business logic that we are using either Python and Apache Spark. Now, even in case of Apache Spark, we are using it both for the streaming and the batch part of it as well, so for all the in-memory processing needs that we have. Now, having said that, while the solution has this particular glossary list of products, it is again kind of, we can always, if our customers or if anyone has, if we want to use an Oracle database, say for example, that can always be integrated as part of the solution as well. So looking at the architecture from a high-level point of view, so we are catering to both the real-time and the batch data sources. We have data coming in for the real-time feeds. We have data coming in from Clickstream. We have data coming in from social media sites as well. We have data for the batch. You might have files or export files being extracted from the different source systems. You might also have data in the form of survey files. So say, for example, like PDF files or email files or an RDBMS system, right? So all that data goes into GlusterFS. Now, once the data is within GlusterFS, we are leveraging S3 API to basically access that data which is available in GlusterFS. And the driver applications run within OpenShift. So the Python job, which generates the sentiment analysis, or the Spark driver job, which basically triggers or submits the job based on the data to an external Spark engine. So in this particular case, we are using external Spark engine, but then we have also developed this solution using Spark on OpenShift as well. Now, apart from that, once the data is processed within OpenShift, all that data goes to MongoDB and PostgreSQL, which is again located outside OpenShift, but it is running on RHEL. And then for integration, we are again using JBoss data virtualization. So all the once the data is available into multiple places, right? So we definitely need an integrated view to be presented for our analytics. So that integrated view is being provided by JBoss data virtualization. And then, obviously, apart from all these different tools that lie within the OpenShift container platform, we are also leveraging Ansible Towers and the other DevOps tools, so Jenkins, Maven for all the build and the DevOps life cycle that we have. So now, having said that, one thing that I would like to reiterate here is, like, again, if you look at all the different products, right, so JBoss AMQ or JBoss data virtualization, DataGrid, 3Scale, these are all deployed within OpenShift. So we have basically created our own custom images. We have leveraged the templates that OpenShift provides, but then we have created our own custom images using those templates, and we have deployed those onto OpenShift. So with this, I'll hand it over back to Brian to briefly go through the use case, and then we can quickly jump onto the demo.
Thank you, Gaurav. Appreciate it. So the use case, or pretty much where we want to take this into a story, is looking at customer analytics in its concept before and how the reality is for this particular role. So we're looking at a portfolio manager in this particular use case for a bank. Again, whatever industry you're in, please, you can swap this out with the role that would be interested in all the data points that we'll be talking through and that we've already mentioned. But this individual knows that all the different information about a particular customer exists in some of those actual siloed areas, whether that is the survey or email data, whether that is the clickstream data and how they interact with the site, where are they coming into your site, where are they leaving, what is their behavior, what is their sentiment, are they tweeting about their experience, are they calling a lot to customer service, how many times in the last month. And for that particular role, the issue is that it's very difficult to get really good insight across all those data sources in the traditional way of customer analytics, where you would have an enterprise software that you'd have to go to different modules to find the information and make, even some ways, the assessment yourself. So what we wanted to take out of that problem statement, as we mentioned earlier, is that we're looking at a particular customer. This customer, Aaron, is actually dealing with different systems and services and offerings from this bank, right? Different accounts. I myself have one bank which has many accounts, so I can relate to Aaron. And then what he's dealing with really is that even though he's proactive, that he's willing to interact with the bank about his issues, that he's getting a little frustrated in that there may be some lag in the time in which his solutions get solved. So whether he's complaining to customer service, whether he doesn't have an issue with sending an email to the right people and try to get that mitigated, those two data points and all the others that he may be interacting with aren't intersecting in any way. There's still some siloed wall in between those sections. So the portfolio manager then goes through 2 attempts to look at exactly what's happened with Aaron. He's been applying for a loan, there's been some lag, some delays, and all of this segmented analysis that he's able to do, he finds out everything about him. He's able to find out and see all the failed attempts. That recently he dropped another mail saying, hey, I've been trying to get this resolved, and you still haven't. And then also, what is Aaron's pattern of behavior? Again, whether that's the social media kind of concept or even just the way that they click through a particular site or place on the site. The loan processing module, for example. All right? And so the issue then is combined so that now that the satisfaction score can be analyzed about Aaron, his churn risk actually goes up because of that lack of satisfaction. And all of this because, again, they see that Aaron's issues are across different areas of input. Data consumption is coming in, but then the portfolio manager needs to find a place to get all that information and run all the analytics and insight on top of that at the same time. Don't want to segment anymore, want it one place. So we see that Aaron's a high-value customer. Again, depending on how you score your customers, your churn risks, and all the other things that we're talking about today and the analytics that he's going to show in a moment will vary, but the model, the framework and solution we built can apply to all of those. All right? So now Gaurav's going to go through the demo. The sake of our reality with the network here, we could connect live. If you come by our booth later on, we can do part of that live as long as that works well, but we've recorded every one of these sections of the solution, and he'll be able to go through them and show you the value of each one as well as the process flow. So, all right, Gaurav?
Thanks, Ben.
Sure.
Okay, so let's look at, so what we'll do is we'll look at each of the data flows that we have as part of the solution, and then we'll go through the demo part of it as well. So when we look at the Clickstream transactions, right, so the way we are doing it is we say, for example, so for the sake of the demo, what we have done is the Clickstream source is a website that is also running within OpenShift. Now that can be, again, we can easily scale up the website depending on the traffic as well. And then we have Red Hat JBoss AMQ, which is again running within OpenShift. So the website that we have within OpenShift or the Clickstream data source, depending on the clicks that we perform within the website, that sends all the data to AMQ. And then we have a Spark streaming processor, which is essentially the driver application, which again runs within OpenShift. That picks up all the messages in real time from the JBoss AMQ, and then that pushes, basically, that triggers a Spark job to the external Spark cluster. So the Spark cluster that we created for this particular solution had 2 master nodes and 2 worker nodes, but then we all know Apache Spark, we can easily scale out as well. So whether it is running on OpenShift or it is an external Spark, we can always scale it out as well. So finally, when all the data is being processed, that data is being returned to PostgreSQL. So, so this is a dummy or the demo bank website that we had created. So as you can see here, this is a portal that is presented to the customers. So so in the home page, we have all the different services that the bank provides, and I can log into the website and I can generate the different clicks. So for the sake of time, what I'll do is I'll just forward it a little bit. Yeah, so basically here what we're trying to show is just trying to show the number of records that we have in the table right now. So that basically gives us an idea as to the amount of data that we have. Now once we verify that, we can see we are basically capturing all the details. So what was the customer ID that, based on the login that we do, what was the customer ID, what was the page that was clicked, what was the time that was spent on that particular page. Now all that data is being again stored within PostgreSQL. So once I log in to the bank website, here, I would be basically presented with generic information, what my account balance is for the different accounts that I have. Now, on the left-hand side, I can also look at the different services that the bank provides, right? So I can browse to accounts, I can browse to statements, I can browse to different bill payers that we have set up within the bank website. Now, all these data, all these transactions that I'm performing within the website generates my Clickstream data that is being written to AMQ. Now, once this data goes to AMQ, we have a Spark application or a Spark streaming job, basically, which reads this data continuously from the AMQ within OpenShift, and that basically processes the data and writes it to PostgreSQL. So now, while this is loading, another important aspect that I would like to mention here is on the, we moved ahead a little bit, but what we've also done is, one major input that we have is out of all the data processing that we're doing, we are also, based on the browsing pattern, we are also generating customer recommendations. So these customer recommendations are again being sent back to the bank website. So as a portfolio manager, as Brian was saying on the use case, I can basically generate recommendations, or I can generate catered recommendations for a particular customer depending on what kind of a customer he or she is. And then I can send those recommendations back to the bank portal as well. So as you can see here, all the data all the clicks that we made in the website, that basically translated to a Clickstream data, and that went to the PostgreSQL database. Yeah, so if you look at the top right-hand side, that is the recommendation that I was talking about earlier. Okay, so the next data flow that we have is customer transactions. Now the customer transactions can be anything from, say for example, if it's a banking use case, the customer transactions can be the banking transactions that the customer does, right? So online payment, bill payment, all those can be online transactions or customer transactions. Now those customer transactions also we definitely want to analyze what kind of transactions the customer does, right? So basically just to analyze their transactional behavior. So that gives us a very good idea as to what the customer mindset is. Say for example, if it's a bank, right? So if I have an account with a bank, and if I'm just withdrawing money out of it, right? I'm not depositing anything. So it might definitely trigger an alarm to a portfolio manager saying that this customer has been with us for a long while, but then recently he has started withdrawing all of his money out of the bank, right? So that is basically, maybe the customer is not happy with the bank. So that can be one of the trigger alarms, right? So that is what we are trying to achieve here. So again, in this case, what we have is, this is the, so this is the driver application that we have created. This is running within OpenShift. Now, as you can see here, for the demo perspective, this is just running on one pod, but this is again scalable depending on the load. Now, this particular driver application would be basically generating or reading those customer transactions, and it would be basically reading it from GlusterFS, and that would be basically processing the data and writing it to PostgreSQL. So in this particular case, what we also did was, as part of the automation, we have created an Ansible Tower job. So that basically what it does is, so say for example, all the source data, say for example, it's a bank customer, right? So you would have different banking systems from which we can extract all the information, right? So you would have all that. I can follow any ETL logic or any ETL tool. Basically, I can use any of the ETL tool and I can extract all that information. So all that data goes within, say for example, is available in an SFTP location. So the Ansible Tower job that we have here, this would essentially trigger, or this would essentially read all those source files from an SFTP location, and it would essentially push all those SFTP files to GlusterFS. The reason for using GlusterFS to store all these files is, again, from audit perspective, or if there is a need for any historical data analytics or analysis that has to be done on all those data, that can be done. And then this particular driver application, so the Ansible Tower would also trigger the driver application that is running on the OpenShift Container Platform. Now, just for the sake of the demo, say for example, we have one particular transaction ID, and then we are just showing that we don't have any records for that particular transaction ID. And when we essentially run the Ansible Tower job, it's going to essentially pick up all those files from the SFTP location, push it to a GlusterFS, and it is going to trigger the driver application, which is again running on OpenShift, to basically process the data and write it to the final database. So we'll just trigger the application, trigger the Ansible playbook here. We'll wait for the results to populate. So as we can see here, what we have done is, for all the driver applications that we are running within the OpenShift Container Platform, we are exposing those driver applications as a REST API. So that becomes very easy for us to execute or to call those REST APIs from the outside, right? So because it can be, so the Ansible Tower again can run within OpenShift, it can be outside OpenShift as well. For our use case, we are running Ansible Tower on top of OpenStack, whereas OpenShift is running on Red Hat virtualization. So as we can see here, the driver application, or the Spark or the driver application has triggered the Spark job, which is essentially reading the data from SFTP location, pushing all the files to GlusterFS, and that would basically trigger the job which processes all the data from these different files, integrates them within the same Spark job, and writes that data to PostgreSQL. So another data flow that we have is the sentiment. So for sentiment analytics, we have 3 different data sources, right? So one of those data sources is Twitter. So again, so say for example, the bank has a Twitter handle, and as an end customer for the bank or any company or any vendor, I can tweet to the bank saying that, hey, I'm not happy with the service that you provided. I've been applying for a loan for a while. I haven't heard back from you guys. What's up? Right, so I can send an unhappy tweet, or rarely do people send a happy tweet, right? So
True.
To the bank, so
yeah.
I can send a tweet, and then basically what we're trying to do here is we're using Twitter API to basically capture those tweets and then store the raw tweets within GlusterFS as well as extract the user details from the tweets and the sentiment, derived sentiment generation or sentiment calculation as well. From the tweets.
You think about, too, in a sentiment standpoint, it can be also the way that you're working within the marketing or PR space of your own organization. If there is a response from a demographic, you can see sentiment data, and that portfolio manager may be able to address that individual based on their demographic and wherever they are within your actual ecosystem of customers. So.
Yep. So again, the reason behind using 2 different databases here is all the unstructured data or the actual tweets, we store them into MongoDB because it's unstructured data. And then only the structured data in terms of the sentiment score that is being generated out of the raw tweets, that gets stored within PostgreSQL. And that is the reasoning we are using JBoss data virtualization as well in the end to basically integrate all these different data sets and then present it to the analytics platform. Now, the other data flow that we have is the email sentiment analytics. So say, for example, we have the bank in question, right? So it has a it has an email address, basically. So as a customer, I can send across an email to them saying that this is what I've been trying to do and I've not been done. Can you please help me out, right? So we wanted to be able to generate sentiment analysis from the emails as well, because considering the multiple channel that the companies today provide to their end customers, it is essential that we monitor all those different channels, we analyze all the different channels, and then basically create kind of a 360-degree customer view. Right, so that is where, even in this particular case, what we are doing is we are using email API to basically capture all the raw email, and the emails are being converted into text format. So the converted text emails are again stored into GlusterFS. Once that is done, we have the driver application. Again, it's a Python application which runs within OpenShift, and we have used the NLTK algorithm to basically generate the sentiment score. So the driver application essentially picks up the text files or the converted email files from GlusterFS, generates the sentiment score, and then that is being written to PostgreSQL. So a quick demo for the email sentiment that we have. So again, as I mentioned earlier, this is the driver application, or this is the application which is running on OpenShift Container Platform. This is a Python-based application, and we are using the NLTK algorithm to essentially generate the, or to calculate the sentiment score. So what we've also done is, as part of this, again, considering the end-to-end automation for all the data flows, we have a Ansible Tower job which essentially triggers. So in this particular case, actually, so this particular case, actually, there was a single application which was essentially reading the data from both, from the email API, writing it to GlusterFS, and then triggering the endpoint to basically calculate the sentiment score. So that is what we are running here. Once you run the Ansible Tower job, it is going to generate the sentiment score and write it to PostgreSQL database.
And based on what you're measuring as sentiment, obviously your KPIs, what you're looking for, you'll score those accordingly as well. Because depending on the industry, it can change.
Yep.
So, yeah.
Yeah. So as you can see here, right, so what we have done is, since we are storing all the data within GlusterFS, we have created 2 separate locations. So essentially the first location is the converted email to text. So the reason to do this is so basically what we wanted to do was we wanted to demonstrate 2 different mechanisms of storing your raw data, right? So in case of Twitter, what we are doing is we are storing all that raw data within MongoDB as unstructured data. But in case of email, what we are doing is we are not storing the raw emails or the text format of the emails into MongoDB. We are just storing a reference of those text files within MongoDB. So the whole reasoning behind is because, so this is just to present two different ways of storing the data for unstructured data within this particular solution. So in this particular case, all the text files that reside on their individual folders for each day, or depending on the kind of scheduling that I have set up, I can easily do that using Ansible Tower itself. So once I run my Ansible Tower jobs, it's going to basically go through the email API, extract all the information from the email address, and then basically inbox, and then basically write all that information to GlusterFS, and it's also going to trigger the sentiment score. It's also going to generate the sentiment score. So while we are waiting for this, basically another point is in case of, so this is again for Twitter. In case of Twitter, what we had to do was we have two different microservices that we had to deploy because we wanted, we are extracting two different information, right? So one information would be for your the Twitter handle that we have. Say for example, I want to get the number of followers or all the other details or all the other metadata for that particular Twitter handle. So we have one microservice which basically extracts all that information. We have the other microservice which essentially does the sentiment score generation. Yeah, so in this particular case, again, I can see as once I run the Ansible Tower job, I can see that there are new folders being created depending on the newer emails that we have retrieved from the email address. And then we are basically generating the sentiment score, and then that is being stored. So as you can see here, we are generating the JSON file. So the JSON file is essentially the formatted data. So we are essentially generating the sentiment score, storing it within GlusterFS as well. So this basically gives you the other path is basically your raw emails. Okay, so now the other data flow that we have is the customer service. This is again another form of generating sentiment score. So say for example, as a bank, I send out surveys to my end customers. The surveys can be in the form of an online PDF form. So they fill out the surveys, and the surveys get sent to the bank or to the customer service representatives as a PDF file, right? So now we would also want to, depending on the type of answers that we have, or depending on the type of options that we have provided as part of the survey, that would also give us an idea as to how the customers feel about the services that we provided, right? So what we have done in this particular case is we have two microservices running in OpenShift. The first microservice essentially converts all the PDF files to text and stores them within GlusterFS. So what we are doing here is we are using PDF miner to essentially read the PDF files, extract the text information from it, and store it as text files within GlusterFS. And then we have another microservice which essentially does the sentiment calculation. So that is again a Python-based microservice. We are using an LTK algorithm to again generate the sentiment score. Now the entire data flow is again being triggered using Ansible Tower. So the last data flow that we have as part of this particular thing is the data integration, right? So now that we have all the different data sets, all the data from all these different channels stored within different tables, so to speak, right, within the database, we would want to basically integrate all these different data points depending on the data pattern that we have, and then basically generate the final data for analytics, right? So this is again being done through Spark job. So we have an Ansible Tower job for this one as well, which basically triggers the Spark job. The Spark job basically reads the data from all these different sources, processes that within Spark, and then that gets written to PostgreSQL. Once the data is written to PostgreSQL, we are using JBoss data virtualization to basically present that integrated view for analytics. So again, as I mentioned earlier, this is the driver application that we have to basically process the data, read the data from all those different source tables, and then process that information and then write it to PostgreSQL.
So here's where you're going to get that view, and especially depending on the role, but you're looking at all those data sources giving you now a much better understanding of the customer, what their needs are, what their issues are, but their sentiment, as well as you're going to see in a moment with all this information, your decisions, your recommendations for next action will be much more insightful and much more accurate. Obviously, every circumstance may be a little different, but it does give you an edge when it comes to retaining your customers and making them have a better experience.
Yeah. So again, because it is on OpenShift, and these are all microservices based, right? So these are all individual microservices deployed within OpenShift, and at the end of the day, they're all working together for the common analytics. But then, because of the microservices nature of it, we can easily scale up or scale down any of these microservices depending on the load that we have, right? So we can also have a scenario wherein we are scheduling some of the microservices are scheduled, or some of the data flows are scheduled more often, and then the integration job is again that because we are using Ansible Tower, we can also have logic built in, which would allow us to ensure that we have all the different data sets in place before we run the integration part of it.
That's where you see all the sources coming in. And this is the dashboard where you actually see this presented. So.
Yeah, so, right.
Yeah, so basically what we're covering here is showing how an individual might interact with this. And obviously, even though this is a dashboard, mock dashboard, you see the tabs, even the ability to move in between some of those sections. The idea is that depending on your role, you're only going to have access to a certain amount of data sets. However, all that data, again, the goal and the real benefit of the solution is that it's all now being calculated in one place. So we're going to start off with it, being a simple dashboard, just kind of calculating and breaking down everything from new loan-to-value calculations. You're looking at new customers and what's the performance, how are they feeling, how are they interacting, and then you're also seeing that combined with customers that you already have. So as we go in, you're going to see just, again, a breakdown from everything from sentiment, the data sources that we already just talked about, that churn risk analysis as well. And as I'm going through this in my everyday, I'm going to at least get an initial snapshot. But I want to be able to dive in a little bit and look into that customer's experience. I want to understand that. We are using Tableau for this dashboard. It could be anything, but for this case, we wanted to really highlight the kind of slicing and dicing on the right-hand side that really makes it a lot easier with this type of dashboard, this type of BI approach. So as the portfolio manager, I'm looking at this, I'm going to want to look at one particular area. I'm going to talk about retaining customers. Again, that is my goal, especially as a portfolio manager. I want to dive into a certain month. I want to look and see what has been the overall experience, who are we interacting with, who are becoming maybe more profitable overall, what segments are we interested in. And since all this data is coming from different places, this solution allows me to see a really nice overview of those data types that exist around those areas, whether that's income segment, again, demographic. We talked already a little bit about the ratio between demographics, whether it's an age segment we're looking at or an income segment, and who are we more successful with. Again, there's a lot of different roles and organizations can work with this type of data, right? A lot of decisions can be made in some of that. And so the other piece, though, we want to look at, too, you can probably forehead just a little bit. So if it's now I've got this overview and a little bit more deep dive into those segments, I may also want to look at the particular customer in that area. We kind of talked about Aaron before, so now we're going to deep dive into Aaron, and this is going to be the actual individual breakdown. So we're looking at Aaron, and everything is being recorded from all those data sources. We now have a really holistic look at this particular customer. And when it comes to here, what we're looking at now is, okay, it's great. Now that I know all that information, that's fantastic. But what should I do then, what should I do to help Aaron's experience be better? And if you look down the bottom right here on the screen, we have something called the recommendations. And this is where the cognitive and AI piece comes into play. Because we're looking at patterns of what has been successful for this type of issue, this type of customer, in this scenario. And so it's giving me a recommendation on what I should do. And that can vary based on your own organization's way that you deal with risk analysis or risk mitigation. In this particular case, it's just a follow-up call. Talk to Aaron. Aaron's very engaging. There are customers like me who just rather do things through my phone. I really don't need to talk to anybody. However, if I'm having a rough time, what is it that you as an organization can do for a customer like Aaron or like me? And that's really, again, the end goal of everything in the solution comes down to relationship. So the relationship of the data that exists, the relationship between you and your own customers, and of course, your relationship between you and the technology. So I think that was it. Anything else?
So as I was again mentioning earlier, the recommendations that we are showing here, this would, So as a portfolio manager, I can browse through the different recommendations that are being generated depending on the customer interactions, the customer browsing pattern, transaction pattern. And then what I can also do is I can essentially select one of those recommendations, and then that recommendation will essentially be integrated back to the Clickstream website. So when I log in the next time, I might see a pop-up on the right-hand side saying that, hey, we are giving you a 10% discount on applying a home loan, say for example, right? Or we are giving you a reduced rate for applying a home loan. So those are some of the possibilities that we have. And then definitely as next best offering or next best actions, we definitely, you look at advanced machine learning or AI capabilities. Those can easily be integrated on top of OpenShift using something like TensorFlow, say for example, right? And we can have those algorithms also integrated with this.